Alrighty people, welcome to the channel. Today we're going through using inverse matrices to solve simultaneous equations. We'll go through three examples, easy one, slightly harder one, then what it looks like in an application process, and we'll go through in this first one basically why the process works, so based on the fact of what we know about inverse matrices and the identity matrix. So let's get stuck into it. Right here we have typical simultaneous equation, pretty straightforward I think, probably to most of us. Now first off we want to be able to set that out in a matrix. Okay, so what we'll have is it basically looks like we take the numbers, put them in one matrix, take the variables, put them in another matrix, and make them equal to the numbers on the other side. Okay. Now hopefully we can see, if we look at it a little bit harder with our knowledge of matrices, we can see that the 3x and 4y, when multiplied by the second column matrix, the 3 and the 4 are multiplied in order so that they're multiplied by the x and the y. So when we're multiplying a matrix, we do our row from left to right by our column top to bottom. That means that we would multiply our 3 by our x, then our 4 by our y, giving us 3x plus 4y. Okay. Hopefully that's all good there. Now, where we go from there is just a little bit different though. So I can get rid of these without erasing my numbers, which I didn't. Let's go back one there. And bang, bang, gets rid of the y. Okay, so how do we solve this? We know that in the past we need to get x and y on its own somehow, or in simultaneous equations, bring it down to a case where we only have an x or a y. Now we can't do that in matrices, so what we use is this. We call these matrices, we give them a name, and we call this A, just for argument's sake, x, and that is all equal to c. So if I write those out here, A times x equals c. Now when we've done a little bit of inverse matrix work earlier, we found out that if we multiply anything by its inverse, that becomes, the product of that is an identity matrix. And we can do that here. So if we go the inverse of A, let's make it a different color just so we can identify what we're doing. So the inverse of A times A and the inverse of A times C, if we do that, we're going to get these two become, as I said earlier, an identity matrix. So I times x equals A, or the inverse of A, times C. After that, what do we know about an identity matrix? Well, we know that an identity matrix times by anything is just that other matrix. So an identity matrix times x is going to give us simply x. So x is equal to a to the negative 1 times c. And what does that mean over here? That means exactly this. If we enter this first matrix into our CAS and then create its inverse, so put it to the power of negative 1, and multiply that by c, the answer over here, we will get the answer to x and y. Okay, so exactly what we've done here. So what we want to do is put it visually a little bit. X and y is equal to the inverse of multiplied by 6 and 4. Okay. Now this is hinging on the fact that the determinant of matrix A, that one there, does not equal 0, which we've been through earlier. So having a look at our CAS now, we can start putting that in. Let's find our math 2. Are we there? So I'm going to just put this in straight up. If we wanted to name them as A, well, I'll go through and name them. Let's do it that way. Let's do it the proper way. So 3, 4, 2, 3, and look, let's name it. It's not already taken. Let's name it A. So I need my name that A, XE, and then we're going to name the next one as 6 and 4, and let's name that one C. Okay, so now I've just named A and C. Now if I multiply those, so I want to do A to the power of -1. So I have A to the power of -1 times C. And I get the result right there of x, y is equal to 6 and 4. Alright, if you asked to answer that question, we'd want it to be x is equal to 6 and y is equal to 4. Okay, and that's the basics, or the start of our basics there. Alright, so let's move on. Scroll down to the next problem. Use an inverse matrix to solve 3 simultaneous equations. So here we have 3 simultaneous equations. I'm going to set it up really similar to before, and we're going to solve it exactly the same way. Alright, I'm going to have a simultaneous equation here. It's going to be 3 by 3. Okay, first thing I'm going to do though is I'm going to set up my variables here. Now in this first one I can see it's set out that I've got x, y and z. I've got just an xy here, and then an x, y, z down the bottom. Alright, so I'm going to put in x, y, z, because that's how they appear in that first one, and I'm comfortable with that. That is all equal to -5, -1 and 3. And now I populate here. So first off I have 3, 4, and the next one I put in as a -2, as you can see just there. 2 is going to take ownership of that. Next line I've got a 2, 2x, a 3y, and nothing for z. So the question we ask ourselves is, do we leave it blank? And we say to ourselves, no, we cannot leave it blank. So how do we create a blank space? Well, if we multiply x by 0, we get 0. So that effectively creates the same thing. In the last one, we've got just an x. Now, hopefully we remember that just an x is the same as 1x. So we have a 1, a 2, and a 3z. And that's our equation there. Let's jump over to our CAS and start punching in some of those. So I'm going to tap that twice and start entering our numbers. A little bit tedious on a calculator, but it's not too bad on an actual keyboard. -2 and 2, 3. Our 0 for our z that's not there. Our 1, 2, 3. Now this one I'm going to put to the power of -1 rather than name it just for my own. Just saves me about 10 seconds. Then I'm going to create another one. So that's our, remember we're doing over here, we're doing a to the -1 times c. Okay, so I've got our -1 done. So our inverse of A done, and then I'm going to put in our -5, -1, and last of all 3. And over here we get that as an answer. So again, we can write it out as such: x, y, z is equal to -11, 7, and 0. Okay, and if you're asked to answer them, like I said, you don't leave it in matrix form. You'll have to put it as x is equal to -11, y is equal to 7, and z is equal to 0. Okay, so that's the triple simultaneous equations. Let's cruise on down to the last part. Okay. Manufacturer makes 2 sorts of orange flavoured chocolates, House Brand and Orange Delights. The number of kilograms of House Brand, X, and the number of kilograms of Orange Delights, Y, that can be made from 80 kilograms of chocolate and 100 kilograms of orange filling can be found by solving the following pair of simultaneous equations. Solve for X and Y. So our House Brand are X, our Orange Delights are Y, and we want to find out what X and Y equals. So the number of kilograms of House Brand, number of kilograms of House Brand chocolates and the number of kilograms of Orange Delight. Okay, so we could set up our, just for being pedantic and correct, set up our 0.3, 0.5, 0.7 and 0.5, and that's equal to X. Sorry, that's multiplied by X and Y, and then that is equal to 80 and 120. Okay, so let's run that through our CAS, and we want a 4 by 4 there, so we're going to go 0.3, 0.5, 0.7, 0.5, that's all to the power of -1, multiplied by our column matrix of C, which is 80 and 120. Let that work itself out, and we get X and Y equal to 100 and 100. Okay, so what's it mean? So we would answer that as in we can manufacture 100 kilos of House Brand chocolates and also 100 kilos of Orange Delight chocolates. Okay, so in the context of the question, we have to state what it is that we've actually achieved. And there we go. That's it in a nutshell. Okay, so I hope that explains how to do simultaneous equations. If you've got any comments for the film, pop them down below. If you like it, give it a quick thumbs up, and if you need to see more, get a bit of a hand through this 2020 VCE year, then subscribe. Alright guys, have a good night. I think I am hitting the hay. Cheers gang. Bye.